Well, hello, fifth grade. Happy Tuesday. No, Wednesday. It's Odin's Day. Sorry. Projecting ahead. So we are knocking on the door, kids. If you flip through your book a little bit past the lessons we're at, this book only goes to 114. So we're going to finish, and you will be the first fifth grade class I've ever finished this book with. So I thank you for your hard work. Today it's kind of a doozy, so I want to jump right in. We are doubling it up, so L111, L112, and we're going to be exploring adding and subtracting mixed numbers. Let's start with this. So whenever I add or subtract mixed numbers, I must ask myself, and if you don't know, just think about that mixed numbers are kind of a fractional form. So hopefully we would all know that we'd have to ask ourselves, are the denominators, and let's all yell it out on the count of three, are the denominators 1, 2, 3 common? It's so important. So we do it with our fractions. We got to do it with our mixed numbers too. So let's say I had this problem, 3 1/5 plus 6 2/5. Always focus on those fractions first. And your first focus should be, are the denominators common? So I look at the denominators of 5 and 5. They are common. Then I'm somewhat on easy street. I can do my 3 plus 6, which is 9, and then my 1/5 plus 2/5, which is 3/5. Nice and what I call easy street, at least in comparison to other things they might throw out at us. So look at this. What if I had 2 1/3 plus 5 1/2? The first thing I want to think about is, are the denominators common? I look and I see that the 3 and the 2, they are not common. Now, as we've explored before, we then want to think about our LCM of our denominators, which ultimately translates to our LCD, our least common denominator. So if necessary for you, you could name out the multiples of 2 and 3, such as like 2, 4, 6, and 3, 6, and go, oh, there it is. But maybe at this point you have enough number sense that you knew it was 6. So I don't require listing out unless it's helping you. And again, another thing we have to then think about is, okay, so I have to take this 1/3 and I have to turn it into a fraction that has 6 as the denominator. And again, maybe that's something you can just kind of brain out. It is something I can do, but maybe you're still in a place where you'd have to write out that 1/3. Maybe you're writing out this kindergarten box and going, okay, it has to have 6. I know whatever goes in the box has to be a fractional form equal to 1. So I'd say, oh, well, I know that it's 3 times 2 is 6, therefore I must multiply that 1 by 2. So again, I don't require that work shown. So if you can do it in your brain, that's great. So I'm going to rename this 2 1/3 as 2 2/6. Now remember, I must do the same with this 1/2. Again, maybe you can brain it. Maybe you need to show this work. I'm not sure what it is for you. People advance at different rates, but clearly 1/2 times 3/3 will get me 3/6. And so I'll rename 5 1/2 as 5 3/6. Then I know my 2 plus 5 is my 7, and my 2 6 plus 3 6 is now 5 6, and I can box that up. Now, adding mixed numbers is not as challenging as subtracting, because subtracting might get us into situations that are a little bit more difficult. It has been my major goal as a math teacher to make sure that we are capable of this. So I'm going to encourage something of you, but remember, my influence over you only lasts for a few more lessons, and then who knows? Who knows who will be teaching you math? But what I would encourage of you, whenever subtracting mixed numbers moving forward in your life, to always stack them up. And I have found that when kids stack them up, they find a greater percentage of success. So I'm going to put this 7 1/3 over 4 2/3, kind of lining things up, if you will. And I'm going for subtraction. Now, here's another thing that can happen. We can never subtract up. Subtraction is a subtracting down. And so be very careful here, because a common pitfall is people will just see that 2/3 and they'll see that 1/3 and they subtract up and they say, oh, that's 1/3. That's just not how reality works. So what's going to be necessary here, because I can't take 2/3 from the 1/3, is it's going to be necessary to do what we call borrow. And in borrowing, we have to be careful and we have to go through a regrouping or a renaming process. So when we're borrowing, that's what we're doing. So what we're going to do is we're going to regroup or rename, and I'm going to walk you through this. So again, I'm going to borrow from this 7. I'm going to borrow 1 from that 7, which would clearly make it 6. Now that 1 I borrowed, I'm going to make equal to a fractional form equal to 1. Now, there's many I can choose from. I could choose things like 2/2 or 5/5 or 3/3. Well, when I say I can choose from them, there's a billion to choose from, but only one will work. 2/2, no bueno in this situation. 5/5, why would I choose that? The only one that would make sense is this 3/3. Why? Because I have a denominator of 3. Then what I do with this 3/3 is I'm going to add it to that 1/3. And so 3/3 plus 1/3 is 4/3. Then I'm just going to rewrite this 4 and 2/3. I'm not doing anything to that. And you can see my problem is now fixed because my denominators are common and I can subtract 2/3 from 4/3. So I focus on my fraction first. I go, okay, so 4/3 minus 2/3 is 2/3. And then 6 minus 4 is 2. And I box that up. Kind of involved, huh? Let's try another one. 6 1/5 minus 3 7/10. Now remember, we're always going to stack. That's what we're going to do. So I'll stack it up, 6 1/5 minus 3 7/10. Remember, what I also focus on first is I focus on do I have shared denominators? And you see I have a 5 and a 10, and I don't. So I'm going to have to rename these as shared denominators. Now, depending on the work level you need to do, basically we need that 1/5 to have a denominator of 10. And again, you can write that out if you need to, but right now I'm going to trust that most of us would know that that is 6 2/10. And then below, I'd say, okay, 3 7/10. Now, be careful again. What will happen is sometimes people see this and they subtract up. You're not allowed to subtract up. So I'm going to have to go through that borrowing or renaming. I cannot take the 7 from the 2. So I'm going to borrow from the 6. I borrow 1 from the 6. That'll make it 5. And that 1, in this case, what should I make it equal to? Yep, 10/10. Then I'm going to add that 10/10 to my 2/10, and I get 12/10. Now, I'm not doing anything to this 3 7/10. So now I'm going to subtract. I focus on my fractions first. 12/10 minus 7/10 is 5/10. And then 5 minus 3 is 2. And now you must know, I can't box that up. Why? Well, because this can be reduced, right? And so I can say, 5/10 is equal to 1/2. So this is equal to 2 1/2. And then I got to box that up. Now, a similar idea can be done if I have a whole number and I'm subtracting off a mixed number. So again, I'm subtracting, so I'm going to stack. So I'll go, 7 minus 1 3/4. And I'm going to rename this 7. Why? Well, it doesn't have a fractional portion to take something from. So what can I rename it as? Again, I'm going to borrow from the 7. I'll borrow 1 from the 7, making it 6. And that 1 I'm going to make worth, guess what? 4/4. Nothing to add it to, so I'll just put 6 4/4. Because 7 is exactly equal to 6 4/4. Now, when I bring this 1 3/4 over, my problem is solved. I can simply do 4/4 minus 3/4, and I get 1/4. And then 6 minus 1, 5. Done. Box it. Yeah. Hey, let's see if we can do some word problems. Go ahead and write it down. It says some campers hiked, that says 7 3/10 miles in the morning. After lunch, they hiked 5 4/10 miles. And the question is, how many miles total? Now, again, be the hiker or be the hill. Be something. Visualize this so that will lead you to the proper operation. If I did some walking in the morning and I did some walking in the afternoon, then how many total? Well, that's an addition concept. Now, I don't require stacking with addition, but you're definitely allowed. Sometimes it's just a better form to see this stuff. Immediately, I should focus on my denominators and go, 10 and 10, that's the same. So now I can just worry about my numerators. So 3/10 plus 4/10 is simply 7/10. And then 7 plus 5 is 12. Now, be careful. Don't box this up because this is a word problem. We must interpret it out and say, that would be 12 7/10 miles. And that I could box up. 12 7/10 miles total. Yeah, that's a good one. Hey, let's do another. Rory, hey, I know a guy named Rory, lives 2 3/4 miles from school. If he bikes there and back, how far did he travel? Again, so be Rory or be the bike. Hopefully you're led to the proper operation, which would be, in this case, addition. So I take my 2 3/4 and I'm going to add it to 2 3/4. Now watch what happens here. Clearly I've got shared denominators, so I can move ahead. And then I'll just go, so 3/4 plus 3/4. But hold on. So that 3/4 plus 3 is 6/4. And 2 plus 2 is 4. Now, this is a strange form, and I'm just going to put here, don't box this. Basically, in the world of mixed numbers, you're never allowed to end with an improper fraction. And that's what we have here. So one thing you can think about is that 4 and 6/4, or 2 and 1/3, or 5 and 1/8, they're all addition problems, where I'm basically taking this 4 and I'm adding it to the 6/4. And then once I separate that out, I can think about my 6/4 and go, okay, I know how to turn that into an improper fraction. 4 goes into 6 one time, and there's 2 left over. So that's 6/4 is 1 and 2/4. And then I'll add this 4. So now I go, okay, 4 plus 1 is clearly 5, 5 and 2/4. Now don't box it up. Why? Well, clearly 2/4 can be reduced. So what would that be? Well, it'd be 5.5. And again, don't box that up because it's a word problem. I'd have to say, oh, Rory biked 5.5 miles. Now you might go, you know what? Funny thing is, Mr. Mirror, I was Rory, or I was the bike, and I was thinking about multiplication. Well, if you look at the lesson title, that's why we're not doing multiplication. But you might wonder, would it come up to be the same if I did 2 3/4 times 2? Yeah, it would. Now remember, whenever multiplying mixed numbers, we have to do that crucial first step. So I'm going to take this 2 3/4, and in that like wraparound sort of way, I'm going to turn that into an improper fraction of 11/4. I multiply that by the 2. I take my cross-canceling opportunities. So this will become a 1. This becomes a 2. So 11/2 is an improper fraction that converts into, yep, you guessed it, 5.1/2. So again, the only reason we did add in this kind of problem is because of the lesson title. But 5.1/2 is the same as 5.1/2. All right, uno más. An old computer, and I mean like an old computer, took 2 and 5/6 hours to complete a task. How'd you like to wait for that? A newer computer took 1 and 1/6 hours. How much faster was the new computer? So again, maybe you're the old computer, maybe you're the new computer, but hopefully you're visualizing and you know, oh, this is a subtraction problem. So remember, when subtracting mixed numbers, let's stack them up. So 2 and 5/6 minus 1 and 1/6. So I've got shared denominators, so I can just go ahead and subtract. 5/6 minus 1/6 is 4/6. 2 minus 1 is clearly 1. Oops, I know I can't do that. 4/6 is reducible, so their GCF is 2, so I'll divide them both by 2 and end up with what will be 1, 4 divided by 2, 1 and 2/3. This is a word problem, so I'd have to say something like 1 and 2/3 hours faster. Yeah? Boom. Yeah. Old computers, obviously. Yeah. You can look at the copyright date on your book and realize that the computer world has moved much further. Hey, guess what? I'm going to give you the split. Yeah, I know. We've done a couple of these lately, but you're just fine. HW111, HW112. At this point, we've also talked about the project, so you are free to be also working on that. But we'll check these tomorrow. Okay? I hope you're well. Bye.